Okay, this is video 7.6, Common Logarithms. Now here we're going to see that our vocabulary is common logarithms, change of base formula, and our objectives here are to solve exponential equations and inequalities using common logarithms, but we'll define that, and evaluating logarithm expressions using the change of base formula. All right, so let's dig deep into go straight into the textbook. So first of all, let's define what does it mean by common logarithm. A common logarithm, all it is when you have a logarithm with a base of 10. And you see here it's written log of x base 10 is equal to log of x when x is greater than 0. So what they're saying here is because it's a common logarithm of 10, this is also an implied logarithm. So if I have the logarithm of x written with no base, it's always implied the common log, which means it has a base of 10. And your calculator, when you hit the log button, it calculates the common log, which means it calculates with the base of 10. So in order to change that base, you have to have an updated calculator that allows you to use the Math alpha button to manually put it in. But a lot of times you have calculators that don't. So let's just practice using common logs. So if I wanted to find the log of 10, they're asking me for the base of 10. So on your calculator, all you have to do is hit log, 5, enter, and you get this long number. So they want you to evaluate it to 10,000 place, which is 4 decimals. This is 0.6990. Find the log of 3. The base is implied 10, so it's a common log, so you can go directly into your calculator and put it in. Pretty simple. That's really easy. That's really what common logs is. They want you to just see the relationship, just like we have 10 to the power of 1 to the power of 2, 3, have a special pattern and a relationship. So does logarithm. So if I have a log base x equal y, that says common log 10 raised to the y equals x. If I have a log of 1, that means a common log of 1, which base 10. So 10 to the 0 equals 1. Common log of 10 is 10 to the first, which equals 10. So they're saying if you have a common log of argument 10 raised to the power m, it's going to, and it equals m, since 10 to the m equals 10 to the m. So we're saying if you have any power of 10, 10 is your argument, 10 is your base. Remember we said if you have the same base and same argument, it equals 1. So they're just showing the relationship there. Now, common logs are used in measurements of sound. So soft recorded music is about 36 decimals. Let's look at example 2. It says the loudness L in decimals of a sound is given by this equation, where I is the intensity of sound and M is the minimum intensity of sound detectable by the human ear. Residents living several miles from a concert venue can hear the music at an intensity of 66.6 decibels. How many times the minimal intensity of sound detectable by the human ear was this sound if M is defined to be 1? So what they're asking us to find basically is what is I, the intensity. Given the loudness is 66.6 and we define M to be 1. So we plug in M for 1 and 66 for L, and we simply just solve this. So remember, 6.66 equal log 10 log of 1. It's just going crazy on me. Log of 1 of I over 1, or I. The problem. Oh, they divide it by 10 here, and they get 6.66. Okay, and so this 10 is going away. So we can rewrite this to say log of I, so my argument, equals 6.66. That's an implied common log, so we raise I equals 10 to the 6.66, which we could put in our calculator and get some value, which they approximate to about 4,500,000. Okay, times the minimum amount. So that's the answer. So all we're doing here is just plugging it in. That's all. We don't need to do with physics about it. Now, if both sides of an exponential equation cannot easily be written as powers of the same base, remember, so we have the same base, then we could solve this x, right? But they don't. 19 is prime and 4 is 2 squared, so you will never have the same base. So we can take the logarithm of both sides, the common log, use our properties of exponents. So here we're going to use the power of power rule. So we're going to move that x right here from here to here. So x times log 4 equals log 19. Now we use algebra. This implies the multiplication. So we divide it. And now we have x common log of 19 divided by common log of 4. And you can easily put that in your calculator because it's the common log if you have an older calculator. And it equals 2.1240. And how can you graph that? If you graph each side, y equals 19 and y equals 4 to the x, where the two lines cross is approximately this value if you do the intersection. Okay, so let's move on to what we call some strategies to help us to solve exponential equations. Right, so we're going to use this for inequalities. So if we can do the same thing for inequalities as we did equations. So we have our base is 3 and 7. Those are both prime, so I cannot change them to the same base and use the exponent rules and set the two powers with the inequality sign between them. All right, but what I can do is I can take the common log of both sides. Now remember, 5y is the power of 3. Y minus 2 is the power of 7. So we put that in parentheses. So we can use the power property of logarithms, and we move the 5y to on this side and the y minus 2 over here. Now remember, this is log of 7. It's factor times factor. I have a binomial, so we're going to distribute. Doesn't matter if it's on the right side or the left side. It still means multiplication. You still must distribute. So they distribute it here on the right side, and then they move the y term all to one side. So then we have 5y log 3 minus y log 7 less than negative 2 log 7. Then we can factor out a y. Then we can divide. We're just using algebra strategies here and properties. And we have y less than negative 2 log 7 over 5 times common log of 3 minus log of 7. So remember, you've got to do this multiplication first. So you put this in your calculator because they're common logs. They're real easy to type in, but you got to make sure you do order. You find this amount, you divide it by parentheses, this times this minus this, close parentheses. And you put in your calculator, you get y less than negative 1.0972. So let's check negative 2, and we get a true statement. So that is our solution. Now, don't get confused and feel that you have to do 5y greater than 0, y minus 2. Okay, those are powers. We said that's only if the argument has a variable, and the argument does not. It's a power, so those are two different things. All right, so if you don't have the same base, so I have a 6, which has a 3 times 2, but that doesn't help me. So I can take the common log of both sides. You would do the same thing here and do what we did up here to solve for y. It's using algebra. Don't let the logarithms scare you. So let's look at the change of base formula. This allows you to have equivalent logarithm expressions that have different bases. So what the change of base formula is, it says for all positive numbers a, b, and n, where a cannot equal 1, and b cannot equal 1. So here we simply log base a of n can be rewritten as a common log of n divided by the common log of a. Okay, so we changed the base b of an old base. So let's look at this one. Common log base 3 of 11. So what it's saying to you is if you have an older calculator where you cannot change the base, you cannot put the base in, you can change the base to the same base and say I'm going to take the common log of 11 divided by the common log of 3. Now you can change it to any base. However, we're going to use common log because then you can use your log button on your calculator. So let's look at this. Let log base a of n equal x. All right? So they're proving the formula is all they're doing. So they take the logarithm of both. They use the power rule, and then they solve for x. And you get the log of base b of n divided by log base b of a. And they prove the formula here. So it doesn't matter what base as long as you have the same base. But if you're changing it because you want to use the common log, then you just leave it as 10. So the change of base makes it very possible to evaluate logarithm expressions on any base by translating the expression to one that involves the common log. And that's what I was saying. So express log 320 in terms of a common log, then round to the nearest 10,000. Well, we use the change of base formula. So we take the common log of 10 divided by the common log of 3. Remember, as long as we have the same base, we can do this. We take the common log of the argument divided by the common log of the base. Now we can put this in our calculator easily, and we get approximately 2.7268. Okay, so what about this one? Log base 6 of 8 in terms of common log. So we take the common log of the argument, which we can write like this because that's implied 10, common log, divided by the common log of the base. Now we can put this in our calculator really easily and get the answer is approximately 1.16. Whatever that was there. Yes. All right. It sounds complicated, but it really is really simple. Look at the rules and the properties and what you're doing. Do the problems, and we'll see you in class.